Good afternoon and welcome once again to the Mobile World Congress 2021 here in Barcelona, specifically in the Spanish Pavilion, where we're giving a space for those Spain-based companies to give us an insight into their innovation practices, their development, and just whatever they want to tell us. I'm joined on stage by Johan Bolin, who's the CTO of Agile Content and Edgeware. It's a Barcelona-based company that specializes in the digitalization of TV services. Welcome, Johan.
Thank you very much.
I think you're going to talk to us about 5G driving innovation in broadcast production. And as soon as you're ready, the stage is yours.
Correct. Thank you. Yeah. First of all, I've been in the telecom and media space for 20 years now, and this is the first time at the Mobile World Congress, and I think it's a quite different show this year than the previous ones. But it's exciting to be here, of course. I'm going to talk about some innovation that we are driving related to 5G. And 5G, of course, impacts the broadcast and the video space in many different ways. As an example, it accelerates an already started trend towards unicast and rich personalization of video services. But it also introduces new opportunities for broadcast production. And that's what I'm going to talk about today. So first, a few words about Agile Content. So Agile Content is actually Barcelona-based, with headquarters here. But we also have offices in Madrid and in Stockholm and in a few other places in the world. So we have pretty much a global coverage. And what we are doing is this. We have more than 15 years of experience of working with digital content. With the acquisition of Edgeware that happened earlier this year, we also have a rich experience from streaming and delivering this digital content over IP networks and over the internet. And with the recent acquisition of FON, we also have a vast experience of managing IP networks and the quality of experience on IP networks. So what are we doing? We do have a fully managed TV service called Agile TV. That's a service that includes content and the user interfaces and even set-top boxes. And we built this service on top of our own technology. And that technology is also available as a technology platform, delivered as a SaaS platform. And next to this SaaS platform, we also have a number of delivery-related products that we can install on net, typically to build your own CDN. But what are we doing then? And so where are we going? So first of all, I mentioned that we are much about the personalization and a rich experience for the viewer that is enabled due to the unicast and the internet-based TV. We also believe a lot in virtualization and cloud, and the reason why we believe in this is because virtualization and especially cloud offers a lot of operational efficiency that in the end benefits our customers with faster innovation cycles and lower cost. But maybe most interesting is that we also see this fantastic technology not only as a way to do what we always have done in a different way, but maybe even more as a change agent to introduce new user behaviors and new TV concepts. And that's exactly what I'm going to talk about today, because this is very related to 5G. So the broadcast challenge. The broadcast industry shares something with the oil industry, that there's an upstream and a downstream. And the upstream and the downstream have, since the introduction of TV, been decoupled in different companies doing it and completely different technology stacks. What have happened the last 10, 15 years is this. As internet was introduced, it started to change how TV and broadcast content was delivered to the user. Meaning on-demand services, consumed on whatever device, and also platforms that were built on web technology and internet technology. On the broadcast side, on the other hand, this hasn't quite happened yet. So the broadcast industry, largely due to the super high bandwidths needed to do broadcast production and the rather compute-intense applications you need to do encoding and so on, broadcast is still very much based on proprietary technology stack that is very, very different from the internet technology stack. We think, though, that this must change. And we believe that there's a lot of things we have done and learned by doing broadcast or by doing TV delivery platforms on the internet that can be reused and repurposed also for the production side. And the reason for doing this is not so much to do things cheaper. They will be much cheaper to do this way, but even more so that will transform the entire concept of TV into something that can be much more personalized and much more immersive for the user. So, there's a few disruption agents that enables all of this, and you have heard about some of this in other speeches today. So first of all, we have GPU and CPU. This has been evolving since the late 70s, but the interesting thing is that just recently, standard CPUs and GPUs available in consumer devices have reached a capacity and also been equipped with support for high bitrate video encoding. And this is very important for what I'm coming to in just a few minutes. Another thing is, of course, the rise of cloud platforms. Cloud platforms offers very efficient operations because you can do, as a vendor, you can operate your software as a service instead of installing it in the customer's premises. It also allows elasticity, but maybe most important, it lowers the entry barriers or the cost barriers to start using advanced technology. Now, this is great, but the problem with this is that if you can't reach it, it can't contribute with any value. And that is where 5G comes into the picture. Because 5G offers access to the cloud and to this GPU capacity and connects the two. And that means that using 5G, you will be able to connect and use these capabilities with cameras or consumer devices wherever they are across the globe. So in order to test if this would really work, we did a proof of concept with SVT. And SVT is the Swedish television. So this is the public broadcaster in Sweden, and by far the biggest broadcaster in Sweden. So what we did together with Swedish Television was that we built a platform that consists of three main elements. So if we start with a small encoder. The encoder here is, as I said, it's an encoder that is based on a standard CPU or a GPU, depending on what you have in the device. But it can run on a standard PC, it can even run on a mobile phone, and doesn't have to be any dedicated equipment. To that encoder you connect either a camera that sits in the same device, could be a camera in a mobile phone, or a camera that you connect to this device via some kind of cable. If in case you have a professional TV camera, it might be an NDI interface or some interface that can connect between the camera and the device where you have the encoder running on. Next to this, we built a contribution network manager as pure software sitting on top of internet. This contribution network manager replaces the satellite links that are typically used today. So if you have an internet and an internet connection that is good enough, you can replace the OB vans that you typically see outside the arenas, and you can replace the satellites and satellite dishes with the internet and with with some kind of modem that provides you with the needed bandwidth. Then we built a source portal and a source manager. This software manages all sources that is registered on the service. So if you want to produce let's say a news show, you register the cameras you want to use for that news show, and you select the cameras you want to use in the portal for this production. And the interesting thing is that so what we have done here is that we have replaced truckloads of broadcast dedicated hardware with just internet and cloud services. And the interesting thing is it works. So actually last week we did a real production of a news show in Stockholm, and this was the lunch news. And we run the entire production through this software to get the production signal out. There are challenges. We have learned several things doing this. One is that platform fragmentation is a challenge. So with platform fragmentation, I mean different kind of computers, might be different kind of laptops, different kind of motherboards, different kind of graphical cards who behave slightly different. So this is the same kind of challenge we have been working with now for more than a decade on the distribution side, that consumers use different devices and you need to adapt to those different devices. The same thing happens on the production side if you want to use consumer devices for production, that you need to adapt the software so it can cope with the fragmentation. Another thing we learned is that audio is in many ways actually more challenging than video. And the reason for this is that there are many different audio codecs and different bit rates of audio, many more than you have for video. And if you want to do a production that uses these different audio codecs, you must have a solution that can, if you will, normalize the audio to some kind of standard format. Another thing we learned is that camera fragmentation is a challenge as well. And with camera fragmentation, I mean, if you take as an example a mobile phone, an iOS device or an Android, an Apple device uses a certain frame rate when they shoot video, while Android devices sometimes uses other frame rates and so on. And this means that if you want to combine sources from different devices, you again need to normalize or re-encode these sources so they get into the same frame rates. And then the question is, what do we do next? Because we, as I said, last week we did this exercise to prove it works. And next on our agenda is this. So first of all, this was a proof of concept. So we are working on introducing more mobile use cases into this. And the reason why we do that is because if we can have mobile devices natively integrated in the broadcast production platform, that will enable use cases where journalists or even regular users like us are using our mobile phones to contribute broadcast video to the TV stations. This might be very useful during concerts or sports events or any kind of event where you don't have a professional camera equipment in place. Robustness, there are still, as I said, this was a POC, so there's still a lot to do on work on the monitoring and redundancy in this solution. So if something happens, that can be recovered or coped with without disturbances on the broadcast signal. And then we have a number of new features and concepts we are looking into as well. And to give you a couple of examples, one thing we are looking into is to use more of the 3D engines that's available on the market today for doing the graphical part of broadcast production. Another thing we're looking into is to use AI for video analysis, to do like AI assisted production, so to simplify for the ones doing the final production in selecting which camera to use and so on. So all in all, the conclusion here is that if you have good enough connectivity, you can use cloud and standard consumer equipment to produce broadcast content of the same quality as you today need professional equipment for. And the important stuff to do that is that the connection must support both the bandwidth but also the quality of service that you need to do that. And that's what 5G brings to the table. So remember the slide I showed previously with the different layers of enablers? What 5G do that none of the previous mobile generations did is introducing support for configuring and managing quality of service parameters that are good enough in order to replace satellite and satellite dishes with a standard mobile network. That is actually it. So any more questions about what we have done, please contact me. And we are happy to tell you more.